In the next assignment, you're going to be combining some skills you've already worked with, calculating probability and combinations. Most of these problems will be multi-step. In general, what we're going to do is use combinations to find the total number of possible outcomes. Then we're going to calculate the number of favorable outcomes. Again, here we might use combinations. And then finally, we're going to find the probability of a particular outcome. So basic probability says that would be the number of favorable outcomes divided by the total number of outcomes. Let's look at a couple examples. A fair coin is flipped 4 times. What is the probability of the coin landing heads up exactly 3 times? Our first step is to find the total number of outcomes from the 4 flips of the coin. So for example, would I have heads, 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 tails, tails, heads? What will those 4 flips look like? On a coin, we have 2 options for each flip. We can either have heads or tails. I have 2 options for the first flip, 2 for the second, 2 for the third, and 2 for the fourth. That means that I have 16 different potential outcomes. Out of those 16 outcomes, I want to figure out exactly how many would have exactly 3 heads. So like heads, heads, tails, heads, heads, tails, heads, heads. We technically could list them all since there's only 16, or we can use combinations. Because basically what we're doing is we're looking at out of 4 flips, we want to pick 3 of them to be heads. What we're really looking at is a combination. We have 4 coins, and we want to pick 3 of them to be heads. Now, if you remember last week, we learned a formula to do that using factorials. We calculate it as n factorial divided by n minus r factorial, where n is our original number of objects and 3 is the number we're choosing. However, I'm going to introduce you to some options. Your calculator will actually calculate this for you, or there are some sites online that have combination calculators as well. If you actually go to Google and you Google combinations calculator, you're going to come up with some different options. I like the one that happens to come up first from calculatorsoup.com. And it shows you that we're doing a combination of n objects and we're choosing r. So in this case, we have 4 objects and we're going to choose 3. And then we calculate that out. It shows the work, so you can double check it. But 4 choose 3 gives us 4 options. So again, I encourage you to use a combination calculator. It will speed things up a little. And we see that there are 4 ways that we would get exactly 3 heads. So now the last step says, well, what's the probability of getting exactly 3 heads? So the probability is going to be the number of outcomes with exactly 3 heads. And that's what we found in step 2, where we found there were 4 ways to get exactly 3 heads. Out of the total number of outcomes, well, in step 1, we found that there were 16 possible outcomes. So that means that there is a probability of 1 in 4, or 25% of the time, we're going to get exactly 3 heads. Let's try one more. A jar contains 8 blue buttons and 7 red buttons. If 10 buttons are picked at random, what is the probability that exactly 4 of them are blue? So first we have to figure out how many ways we can pick 10 buttons from the original jar that has 15. So that gives us a combination of 15 choose 10. Again, go ahead and use your combination calculator. My number of objects I'm picking from is 15. I am choosing 10 of them. So 15 choose 10 tells us that we could have 3,003 options. Now this question says that we want exactly 4 of them to be blue. So we're going to look at the number of ways to pick 4 blue from the jar that originally contained 8 blue. So again, we're looking at a combination. Out of those 8 blue, I want to choose 4. So 8 choose 4 shows us that there are 70 ways that we could pick 4 blue buttons out of the 8 that were possible. However, we can't stop by just thinking about the number of ways to pick 4 blue. Because remember, we're picking a total of 10 buttons. So if 4 are going to be blue, that means that the other 6 must be red. So we're going to do another step, and we're going to find the number of ways to pick 6 blue buttons, or sorry, 6 red buttons. So I just fixed my typo. We're going to find the number of ways there are to pick 6 red buttons from the original jar that contained 7 red. So our combination of 7 choose 6, 7 choose 6 is actually 7, because essentially what you're doing is you're picking one that you're not selecting. So I wrote down 7 ways to choose my 6 reds. So we need to essentially combine that. We want 2 things to happen. We want to pick exactly 4 blue and 6 red. These are 2 events. So we're going to multiply them to find the probability of both of them happen. So we're looking at the number of ways to pick 4 blue and 6 red. So I'm going to take my answer from step 2. There's 70 ways to pick 4 blue, and there's 7 ways to pick 6 red. 70 ways to pick 4 blue times 7 ways to pick 6 red gives me 490 ways to pick 4 blue and 6 red. Now we write it as a probability. So what's the probability of exactly 4 blue buttons? Basically, that's the number of ways we're picking 4 blue and 6 red, which we just did, divided by the total number of ways to pick 10 buttons from the 15. So we just did the 4 blue and 6 red. That was 490. And the total number of ways to pick 10 buttons came back from step 1. 15 choose 10 was 3003. So my probability is 490 out of 3003. You can change it into a decimal or a fraction. So dividing that out, that's 0.163 or 16.3%. As you can tell, these problems are multi-step, so go through step by step and take your time.